Welcome to lesson number 4. We're working on part 2 of addition and subtraction of rational expressions. So same thing, I'm only going to do a few of these examples, and then other ones I can help you if you want to fill in all of them. You could either do it yourself or I could help you with those in class. Now, this first one we're going to look at is denominators with factors in common. So 5x plus 5 and 2x plus 2. Before we actually get into determining what my common denominator is, I need to start by factoring this. And so both of them, as you'll soon see, have a factor of x plus 1 in their denominator. So if I factor this denominator, it's going to become 5 times x plus 1 plus 3 over, if I factor the 2 out of this one, x plus 1. Now what I can do here is I can find a common factor. If I multiply 5 and 2, I would have 10. So both of those go into 10, and that's the denominator I'm going to use. Now in order to get to 10, I'm going to have to multiply everything on here by 2, and everything over here I'll have to multiply by 5. So what that's going to leave me with is 4 times 2 over 10x plus 1 plus 3 times 5 over 10x plus 1. And now I have my common denominator, and 4 and 2 is 8, plus 3 times 5 is 15, all over 10x plus 1. And when I simplify that, I'll be left with 23 over 10x plus 1. And if I look at my restrictions on the variable, because we want to indicate our non-permissible values, my value of x cannot be equal to -1. My next question I'm going to look at is if I have a binomial equation, and with this binomial expression as my denominators, you might notice that the only thing they have in common is x minus 2, and then this one has x plus 4, this one has x plus 1. So in order to come up with a common denominator, I'm going to have to multiply everything over here by x plus 1, and everything over here I'm going to have to multiply by x plus 4, because that's the only thing that's missing on this side. But remember, I'll have to do that on the top and the bottom, which is going to leave me with 5 times x plus 4 plus 2 times x plus 1. And all of that is going to be over x plus 4, x plus 1, and x minus 2. So if I combine my like terms, I'll first expand. That leaves me with 5x plus 20 plus 2x plus 2, all over x plus 4, x plus 1, and x minus 2. If I simplify this even further, I'm going to be left with 5x and 2x is going to give me 7x. 20 and 2 is going to give me positive 22. And my denominator, x plus 4, x plus 1, x minus 2. And that's as simplified as we're going to get. However, we do need to include our non-permissible values, or our restrictions, where x cannot equal -4, -1, and positive 2. So this example is similar. The only difference is that, so with this class example number 3, the only difference between this one and the previous example is instead we have p squared minus 1, which is a difference of squares. So we could factor this as p minus 1, p plus 1, in which case we'll have to multiply this side by p minus 1. But if we have a situation where we have our denominator as a trinomial, it's going to be a little bit of a different situation in this case as well. So before we even begin, what is going to be helpful is if I first factor my trinomial. And so I can just factor this by inspection. I have y minus 1 times y minus 2 and this one by inspection as well, y minus 1 times y plus 2. So the only different term that they have is this, well, this one has positive 2, this one has negative 2. So over here, I'll have to multiply by y minus 2 on the top and on the bottom. And on this side, I'll have to multiply by y plus 2 on the top and on the bottom, which is going to leave me with 1 times y plus 2 plus 3 times y minus 2. And all of these over y minus 1, y minus 2, and y plus 2. So if I expand this, I'll be left with y plus 2 plus 3y minus 6 over my denominator of y minus 1, y minus 2, y plus 2. And I'll need to combine my like terms, giving me y and 3y is 4y. Positive 2 and negative 6 would be negative 4 over y minus 1, y minus 2, y plus 2. Now that I'm here, in order to simplify it into my simplest terms, I can factor my numerator. 4y and negative 4 are both divisible by 4, so I can pull that 4 out, which would leave me with y minus 1 over y minus 1 times y minus 2 times y plus 2. And remember, we can cancel out not terms but factors, so those will cancel out, leaving me with my simplified expression, which is 4 over y minus 2, y plus 2. And stating the restrictions on these variables, y cannot equal plus and minus 2, so positive 2 here and negative 2 here. But if we look at the term that we canceled out, it also can't equal positive 1. Next example is very similar to the first one. However, before we start this one and begin finding what our factors are, we do have to factor it completely. And if I look at what's on the top and the bottom and top and bottom, they're all trinomials, and they're all trinomials where my value of a is equal to 1. And so with ax squared plus bx plus c, a is equal to 1, which means I can factor by inspection. So if I look at this first term, and this is my first term right here. If I start by factoring that one, I'll have x minus 1 and x minus 2. If I factor the denominator, I'll have x minus 1 and x minus 4, and I am subtracting, if I factor both the numerator and the denominator, x plus 4 and x plus 6 divided by x plus 2 and x plus 6. Okay, so now that I've gotten this far, I can cancel out any factors that show up twice. So x minus 1 and x minus 1, those will cancel out. And x plus 6 and x plus 6 also cancel out, leaving me with my simplified version of x minus 2 over x minus 4. And I'm subtracting x plus 4 divided by x plus 2. So now I have my denominators, which I now need to find my lowest common multiple of. And so my lowest common multiple of x minus 4 and x plus 2 is going to be x minus 4 and x plus 2. So on this side, I'll need to multiply everything by x plus 2. And on this side, I'll need to multiply everything by x minus 4. Which is going to leave me with x minus 2, x plus 2, minus x plus 4, x minus 4, all over x minus 4, x plus 2. And you might recognize that these are difference of squares, and so this is going to be x squared minus 4, and subtract x squared, and if I were to bring this negative sign in, that's going to be positive 16 over x minus 4 x plus 2. So in simplifying this, we're going to be left with, I don't have any x squareds because those will cancel out, but negative 4 plus 16 is going to leave me with 12 over x minus 4 x plus 2. Now, when we list our restrictions, x can't equal any of the restrictions that were part of my denominators. So if I look at right up here before I canceled out my factors, my restrictions were x can't equal 1, x can't equal 4, and x can't equal negative 2 or negative 6. So these are all my restrictions on the variable x.